approximations. So I want to approximate to 6 decimal places using Maclaurin series to evaluate this integral. So looking at this integral, you can see this cannot be done with parts or any other way. So the only way we could do this is with the Maclaurin series. So breaking it down a little bit by bit, cosine of x is this. So substitute in the 3x squared and then multiply by x squared. All right, so remember this 2n moves to the 3, and this 2n times this 2 gives us 4n, and then add on this 2, so I get 4n plus 2. All right, so I'm going to put it in the integral. And remember, you're integrating. That means you're adding 1 to the exponent of the x only. Everything else carries along, right? So this 2n factorial carries along. 3 to the 2n carries along. Negative 1 to the n carries along. Okay, so you add 1 to the exponent of 4n plus 2. You get 4n plus 3 divided by 4n plus 3. And then you evaluate it between the limits of 0 and 1/4. So you will always see a 0 on one of the limits of integration. So you just have one sum to worry about. And so I'm going to write out several terms. Remember, most of these Maclaurin series start at 0. So be careful you put in n equals 0 first. So here's the first term, there's the second term, there's the third term. So you just need to write out a few terms until you see that, oh, look at that. That does not affect the first 6 decimal places. So what is the approximation to this integral? Would just be those two added together. All right, so let's go do this one. Approximate to 6 decimal places. All right, so first off, I'm noticing, I think this is going to use the 1 over 1 minus x is equal to x to the n, correct? So I have to get a 1 and an x from this here that I've got. So I've got x cubed, and I'll just pull it off to the side. So first I'm just going to multiply top and bottom by 1/4. So I'm going to pull the 1/4 over here. And this 1/4 in here will make a 1 plus x to the 5th over 4. So remember, I have to have a 1 and I have to have a subtraction sign. So this x cubed over 4 stays out in the front. So I have 1 minus a negative x to the 5th over 4. Okay, so I want to use this, correct? So this is going to be x cubed over 4, the summation of negative x to the 5th over 4, all to the nth power. So this is the same as saying negative 1 to the n, x to the 5n, 4 to the n. So you're being really careful to distribute this n to this negatives to make negative 1 to the n, right? This nth power to the 4 in the denominator and the nth power to the 5. Okay, so let's join these things together because I want to have 1x, correct? So if I join this x cubed and this x to the 5n together, I get 5n plus 3. And then just to make it nice and clean, I'm going to put the 4's together. This is 4 to the 1 and 4 to the n. So I have 4 to the n plus 1. Okay, so this is what I can put inside my integral. So I'm going to integrate x to the 5n plus 3 over 4 to the n plus 1 dx. Okay, so from 0 to 0.4. It's always going to be a small number, so don't ever think you're going to be putting in the number 4 because that won't be small, right? I want it to 6 decimal places, so these numbers should be getting really small. All right, so it's n equals 0 to infinity. So I'm adding 1 to the exponent, right, to integrate. So 5n plus 4. This carries along, 5n plus 4. And I'm evaluating between 0 and 0.4. So I have negative 1 to the n, 0.4 to the 5n plus 4. And 5n plus 4. Okay, so now I'm ready to go plug in some terms. Turn it off for a second, and I'm just going to use my calculator and get some numbers written down. Okay, so I just took some time to plug in n equals 0 into here, got this. plugged in n equal 1 into here and got this, and n equal 2. So then I figured out what this number was. It was this. So I still need this. This still affects the first 6 decimal places. This only has 5 zeros, so I still need this. This number, when I plugged in n equal 2, I got 2.99 times 10 to the negative 9. That does not affect the first 2 decimal places. So the approximate integral would be these two subtracted.